Hey everyone, it's Miss Spivey. Today we are going to start looking at Unit 4, which is on bonding. Okay. In order to participate in this lecture, you need your Unit 4 book. You need a periodic table. You need a pencil. I would have a separate sheet of paper that you can draw the examples on so that you can be looking at your unit book and drawing examples at the same time. And you might need a calculator if you need one to help you just do some basic math. So again, Unit 4 book, periodic table, separate sheet of paper, maybe a calculator, and you definitely need a pencil. Okay, so we are talking about chemical bonds. So the first thing I want you to do, if you missed the first day's worth of Unit 1 or Unit 4, all we did was cover page 2 and 3 in your Unit 4 book. Page 2 and 3 go over the difference between an intramolecular force versus an intermolecular force. And we also talked about types of intramolecular forces: ionic, covalent, and metallic bonds. Okay, and you can read all of that information on page 2 and 3 of your Unit 4 book. We are going to pick up today on page 4. Okay, picking up on page 4. So the top part of page 4, what part of the atom is involved in chemical bonding? The answer, the valence electrons. The outermost electrons are the only subatomic particle involved in bonding. So valence electrons are the most important part of the atom when it comes to bonding and chemical reactions. Okay, the valence electrons are important. So in Unit 2 and also again in Unit 3, you learned about valence electrons. Sorry about I'm not a very good artist. Oh, I didn't know that was going to happen. Sorry, y'all. So we learned about valence electrons. Group 1 has 1 valence electron, Group 2 has 2, 3, 4, 5, 6, 7, and 8. Okay. We also talked about how 8 is the magic number of valence electrons. Okay. That is our octet rule. Every atom wants 8 valence electrons in order to be stable. We do have exceptions. Hydrogen and helium are very, very small, so they are happy with 2 valence electrons. Okay. But you should know helium's a noble gas, so it already is happy as it is, okay, because it already has 2 valence electrons. So this should be a complete review for you. So if you will, flip in your unit book to page 6, and I want you to look at the very top of the page. The top of the page is on electron dot structures, okay? The instructions say draw the electron dot structure for the following atoms. So hydrogen, I would just write the symbol H, and then if I'm drawing the electron dot structure, I'm only going to draw the important electrons, the valence electrons. So hydrogen has 1 valence electron, so that means that I'm going to draw 1 electron dot. You can pick whatever side you want it to go on. Here, here, here. They're all right. They're all the same thing. Okay, so there's hydrogen's electron dot structure. Okay. Next, helium. Helium has 2 valence electrons, so I'm going to draw 2 electron dots. The only catch is I'm not going to double up my electron dots until I have 1 dot on every side. So I just have 2 dots around helium. Okay. Boron has 3. 1, 2, 3. Again, don't double up until you have 1 electron on each side. So pause the video. You finish 4 through 9. The electron dot structures for nitrogen, carbon, neon, fluorine, xenon, and phosphorus. All right, so after pausing the video and drawing your electron dot structures, this is what you should get. Nitrogen has 5, carbon has 4, neon has 8, fluorine has 7, xenon has 8, and sorry I forgot about phosphorus, it would have 5 because it's in group 5. Okay, so again, you look at the group number that the atoms are in, you draw their valence electrons representing with dots. Okay, that's the base of electron dot structures. So one note that I want you to write to yourself at the top of page 6 is that this is the only time, let me find a good spot. Let me erase some things here. Okay, electron dot structures are going to be the only time I have single electrons. Okay, every other time we are working and drawing anything having to do with Lewis structures, we are working with pairs of electrons. An electron pair means that you have 2 electrons. So we're either going to represent our electron pair with dots or a line. Okay, so I want to go over some vocabulary words with you before we dive in and start working with Lewis structures in your notes. Okay. So on my screen right now, I have the proper Lewis structures for water and carbon dioxide. The point of the lecture, today's lecture, is for you to learn how to draw the Lewis structures according to the right steps. So what I want to cover with you right now is just a couple of vocabulary words. Okay, so as I mentioned on the previous slide, we are working with electron pairs. So that means 2 electrons. So within this region right here, let me use a different color. Within this region right here, there are 2 electrons shared. That is a covalent bond, or what I would call a shared pair. Okay, that pair of electrons is shared between the hydrogen and the oxygen, and that's the only place where it can go. Same as here. This is a bond, not just any type of bond, a covalent bond, because it's between 2 nonmetals, hydrogen and oxygen. Now, these dots right here are going to be called lone pairs. They go to oxygen alone. They only belong to oxygen. Okay? So down here, if you look at carbon dioxide, CO2, carbon dioxide, I have 2 shared pairs here. So that's going to be a double bond. Okay? So that means that there are 4 total electrons represented here. Okay? But these are still lone pairs, just 2 electrons. Okay, so really be comfortable with the terms shared pair and lone pair. Okay, I'm going to use those terms a lot. So a lone pair goes to 1 atom, whereas a shared pair is between 2. Now, I emphasize with my students all the time that chemistry is not creative. There's not a place, there's really no creative outlet. It's very picky. Okay, so some things that I want to note just before you get started drawing Lewis structures. Okay, when it comes to our atoms and lone pairs, electrons want to be as far apart as possible. Okay, so if I'm drawing, hold on just one second. Okay, the first picky piece that I want to talk to you about your Lewis structures is just making sure that you are spreading your atoms and therefore your electrons out as far as possible. So if you look here at this methane molecule that I have drawn, I have carbon in the center with 4 hydrogens on the outside. My hydrogens are as far apart as they could possibly be. They all have their own individual side on the carbon. Okay. We talked a lot in Unit 2 about how electrons are negative, and so therefore they repel each other. Okay. So that's why I need to position my bonds to where my atoms are as far apart as possible because of repulsions within the electrons. Okay, so I don't ever want you to draw it like this, where you have your carbon and then it's lopsided and has all the hydrogens on one side. Okay, again, here's the correct way to draw water, not here. We're not trying to bunch everything up. Spread the atoms out, give them their own individual space. All right, the next thing. We're going to draw some very large molecules like this one. This is what we'll do in the next lecture. You can see that I have iodines, 3 different iodines in a bond, okay? But the lone pairs are always as close to the atom as they can be, okay? You're hugging them up tight against what they're doing. So lone pairs are never going to come off and look like this, okay? They are within the atom. They are not spread out. Okay, so make sure you keep your lone pairs tight together. Okay, so the only bit of creativity that you get within Lewis structures is if you want to represent your lone pairs as dots, like I have in all of my images before, or if you want to use lines. Okay, so again, the lines that you're using represent 2 electrons, and they have to be as close to the atom as possible, like this. Okay, again, each line here, this would still be a lone pair because it's not between 2 atoms, whereas this one is a shared pair. So the one bit of creativity you get, do you want to be a person who uses dots or lines to represent lone pairs? Okay, so now what I want you to do, I want you to go to your unit book. I want you to flip back over to page 4. Okay, so on page 4, I'm going to start reading you the rules of Lewis structures. Okay, so the top paragraph. Lewis structures allow us to predict the arrangement of atoms within a molecule, determine the geometry, and help understand how molecules interact. Lewis structures are only drawn for covalently bonded molecules. That's something that's worth highlighting. Covalently bonded molecules, things that happen, bonds between nonmetals and nonmetals, are the only type of molecules that we draw Lewis structures for. Okay, when you have ionic structures or metallic structures, they have they are crystalline. Okay, so the middle of the page shows you types of bonds: single, double, triple. Multiple bonds is going to come into play in the next lecture. So I really want to focus on the bottom of page 4 where it says rules for determining Lewis structures. So get out a highlighter. Get out a highlighter and highlight some things with me before we get going. So number 1, highlight, determine the total number of valence electrons in the molecule or polyatomic ion. That's where your periodic table comes into play. Okay. Step 2, you're going to divide by 2. Step 3, the element with the lowest electronegativity is the central atom in the molecule or polyatomic ion. So let's think for a second. We learned in unit 3 that fluorine has the highest electronegativity. Okay. So that means that our central atom in our molecules has to be as far away from fluorine as possible. So if you want to make that note, number 3, find the atom that's farthest away from fluorine. Okay. Number 4, it says hydrogen is always a terminal atom. So if you want to write up above it, that means it's on the outside. Hydrogen can never go in the center of our atom because it only ever wants 2 total electrons. It's small. It cannot bond any bigger than 2 total electrons. Number 5, place 1 pair of electrons as a dash representing a single bond between the pair bonded atoms. So you're going to make a shared pair. Number 6, you subtract the pairs used from the total you had available. Number 7, you're going to place lone pairs around the terminal atom to satisfy the Octet Rule. Leftover pairs go to the center. And number 8, if the central atom is not yet surrounded by 4 electron pairs, convert 1 or more terminal lone pairs to a double or triple bond. Number 8 is what lecture 2 is going to focus on. Okay, so you're probably very overwhelmed because you're like, oh my gosh, she just read so much stuff to me. I don't know what any of it means. I want you to keep your unit book out next to you where you can read your steps that I just read to you, okay, and have a separate sheet of paper where we are going to draw some structures, okay. So the first thing that I want to do, I want to draw NF3 with you. So this is our molecule, NF3. NF3. So step number 1, according to my rules, says to determine the total number of valence electrons. So I look at nitrogen. Nitrogen's in group 5, so it's going to bring 5 valence electrons to our picture. Okay. Fluorine is in group 7, but there are 3 fluorine atoms, so that's going to give me 21. So 5 plus 21 gives me 26 total electrons. Just a helpful hint. After step 1, you always have to have an even number of electrons, because if you read step 2, we're going to divide by 2. So 26 divided by 2 gives me 13 electron pairs. So remember, our pairs of electrons can either be shared pairs as bonds or lone pairs around one atom. Okay? So step number 3, the element with the lowest electronegativity goes in the center. So fluorine is obviously the highest electronegativity, so I'm going to put nitrogen in the middle, fluorine on the outside. Okay, turn the page over to your notes. Hydrogen's always a terminal atom. Doesn't apply to me here because I don't have hydrogen in my structure. Number 5, place one pair of electrons as a dash representing a single bond between each pair of bonded atoms. So I'm going to have a bond between nitrogen and fluorine 3 different times. So I have 3 shared pairs. Step number 6, subtract the number of pairs used from the total number of pairs you had available. I had 13, I've used 3, so I have 10 pairs left. Okay, so number 7, place lone pairs around the terminal atom to satisfy the octet rule. Leftover pairs are assigned to the center atom. So what we're going to do now, as I've already mentioned, the octet rule is that everybody wants 8 valence electrons. That's what we want. So we're going to fill up the sides, fill up our atoms on the outside to where they are satisfied and happy with 8 valence electrons. And then if I happen to have any left over, then I'll put them on the center. So fluorine here, this fluorine that I'm writing on, fluorine already has 1 or 2 valence electrons with it, so 1 pair. Maybe that's 8 valence electrons is the same thing as having 4 electron pairs, okay? Either they're shared pairs or lone pairs. So I have 1, 2, 3, 4. So there, I've used 3 pairs so far. 3, 4, 5, 6, 7, 8, 9. So I had 10 pairs. I have 1 left over. Okay. So that leftover pair is going to go on nitrogen in the empty space that is available. There we go. So here's the correct Lewis structure for NF3. So again, you could draw this same structure. You could have this same structure, but instead of dots for your lone pairs, you have bars, you have dashes, okay? The only thing you need to make sure that you remember, keep the lone pairs as close to the atom as possible and make sure that you only have, that you're giving all of the electrons plenty of space, okay? So the last thing you should do is count and make sure that every single atom has 4 pairs or 8 total valence electrons to it, okay? So this fluorine here has 1, 2, 3, 4 pairs, it's happy, okay? This fluorine here has 1, 2, 3, 4 pairs, it's happy. This fluorine here has 1, 2, 3, 4 pairs, it's happy. 1, 2, 3, 4 pairs on my nitrogen, it's happy too. Please do not put little dashes on your pictures. I'm doing it because I want you to be able to see what I'm counting and how I'm counting. I'm not going to put dashes on any other pictures from this point forward. I was just doing that for visual sake. Okay, so let's do another example altogether. All right, next up is CHCl3. CHCl3. Step number 1, find the total number of valence electrons. Carbon's in group 4, hydrogen's in group 1, chlorine's in group 7, but there are 3 of them, so that's going to give me 21. So 21, 22, 26. 26 total electrons. All right, now what we need to do, step number 2, divide by 2. 13 electron pairs. So I don't want you to think that I'm just making up the steps as I go. Everything comes from page 4 and 5 in your unit book. Page 4, page 5. Okay, so I have divided by 2. Step number 3, the element with the lowest electronegativity is the central atom. So when I look at carbon, hydrogen, and chlorine, hydrogen does have the lower electronegativity, but if we read number 4, hydrogen is always a terminal atom. It's very small. It cannot go in the center. So I'm going to have carbon in the center, hydrogen, and then 3 chlorines on the outside. Okay. Step 5, place one pair of electrons as a dash representing a single bond. So I'm going to give some shared pairs. So 4 shared pairs here. Everybody spread out. Subtract the total, the pairs used from the total. So 13 minus 4 gives me 9 pairs left. Okay. And those 9 pairs, it says, number 7, place lone pairs around each terminal atom except for H. Okay, so cover up hydrogen in your picture. It will never have dots. Hydrogen will never have dots. Hydrogen will never have dots. It is small. It only wants 2 valence electrons total. So my 9 pairs are going to go around my chlorines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have used up all 9 pair. I don't have any left over. Now we're going to count and make sure that everybody has followed the octet rule. That's the whole point of these bonds, y'all, is the octet rule. So pick a chlorine, 1, 2, 3, 4 pairs, 1, 2, 3, 4 pairs, 1, 2, 3, 4 pairs. The carbon in the center is happy, 1, 2, 3, 4 pairs. Hydrogen is a weirdo. It's supposed to be, okay? No dots, not 8, only 2. Okay, hydrogen is an exception. All right, let's try one more altogether. Let's try phosphate. If you don't know what I'm talking about phosphate, then you need to study your polyatomic ions. Phosphate, formula and charge is PO4 with a -3 charge. Okay, so step number 1, total number of valence electrons. Phosphorus gives us 5. Oxygen is in group 6. 6 times 4 is 24. And you're like, well, 5 plus 24, that's 29. Miss Spivey, you said it always has to be an even number. Exactly. We have to take into account this -3 charge right here. Remember, this is an anion. Anions add electrons. So I need to add 3 electrons on. So 27 plus 5 is going to give me 32 total electrons. All right, 32 divided by 2 gives us 16 electron pairs. So I just did step number 1 and step number 2. Step number 3, I pick an atom to go in the center. It's going to be phosphorus because it's farther away from fluorine. So I'm going to put 4 oxygens on the outside. You might say, well, how did you know you needed 4? Right here in this chemical formula, y'all. So step 5, place 1 pair of electrons as a dash representing a single bond. So I'm going to have 1, 2, 3, 4 shared pairs. Step number 6, subtract the pairs used from what we had available. 16 minus 4 is going to give me 12 pairs left. This subtraction step is the most frequently forgotten step. Okay, so step 7, place lone pairs around each terminal atom to satisfy the octet rule. So I'm going to pick an oxygen and fill it up. So here's 1, 2, 3 of 12, 4, 5, 6 of 12, 7, 8, 9 of 12, 10, 11, 12 of 12. So here would be phosphate, PO4 with a -3 charge. Okay, so all of the Lewis structures that I have drawn for you today are simple single bonded molecules. Okay, you can also double check your structure and make sure that everybody has 4 pairs or 8 total electrons. Okay, so big things to take away from this. Remember, we're working with pairs of electrons, 2s, either shared in a bond or lone pairs. Okay, and we are following the steps on page 4 and 5 of our unit book. Keep your unit book next to you until you are comfortable to do this all on your own. Okay, so what you need to do to practice simple single bonds, I need you to go over to page 6 in your unit book, page 6, and I want you to finish the bottom, finish part 2. So that's 1 through 9. There are 9 different structures for you to draw. You should have plenty of room to draw them. So draw them in your unit book. Okay. If you need any further help, you need to see one of the Chem Squad teachers, and they will help you. Lewis structures just take time. Okay. So if you need help, ask for it. In the next lecture, you're going to look at double and triple bonds, as well as exceptions to the octet rule, and when your center atom can hold way more than 8 total electrons. Thank you for watching.